Okay, so as I said, the quiz yesterday, it was, we didn't do quite so well. So here's your spoiler alert. I have already set up the quiz for tomorrow. It's going to post at 3:20 today, and it is exactly like yesterday's quiz. If not the same questions. It's 3 that are in formula form, where you will have to write it out in formula form, balance, and identify the type. And then there are 3 that are in words. There are 3 that are in words, and you'll have to write out in formula form, identify the type, and balance. Okay? So it's almost like a do-over. Okay? Almost, and then I'm not omitting that first one. Okay? But it's another chance to do better on this. Okay? So here's some questions that are like that second set of 3 questions. I'd like you to try 1 through 3 here first. Okay? And we'll go through those, and then we'll look at a couple more. Okay, and then we'll go back to kind of predicting a little bit, balancing a little bit, okay, those kinds of things. Okay, now when we go over these examples, okay, like follow along and check what you've got and be honest with yourself, okay? Because I think what's happening here is that people are doing the quiz at home and they're like, oh, I only made 1 little mistake, so it's not a big thing, correct it. But can 1 mistake cost you more than 1 mark? Yeah. Okay? If you forget something like that an element is special, you're going to lose the mark for the reaction because the reaction won't be right, and you won't balance it right either. That means 2 out of 3 marks are gone because of 1 little mistake. So you got to be honest with yourself when you're looking at, oh, I made a little mistake. It is a little mistake, but it's costly. Okay, so be honest with yourself when you're looking at how many mistakes do I make on a quiz like this or on a question like this. Okay. All right. So iodine. What does iodine look like? I2, it's one of our special elements. Okay, and it reacts with magnesium, which is not special. Okay, to form magnesium iodide. All right, so Mg with I. Okay, what kind of compound is that? Ionic or molecular? It's ionic. What do I need to do with it? Drop and swap. Okay, these are the little details that I think a lot of us forgot on that quiz yesterday, Mgi2. All right, so now that's dropped and swapped, and now I can look at my balancing for the whole reaction. Looks good. There's 2 iodines on both sides, 1 magnesium on both sides. Reaction's balanced. Okay, all right with that first one. What kind of reaction is it? Synthesis. Okay, for question number 2. Copper 2 nitrate. All right, Cu, okay, and then with nitrate, NO3. And nitrate's a -1. And what's the charge on copper? 2. Yeah, according to the Roman numeral, it's +2. This is something that absolutely scorched people on yesterday's quiz. When I do this drop and swap, what do I have to put around the nitrate? Brackets. Okay, a lot of people forgot brackets around their polyatomic ions yesterday, and that is a costly mistake, right? Not only do you miss the reaction mark, you miss the balancing mark because your reaction isn't balanced properly either. Okay. All right, CuNO3 and it's reacting with sodium, which is Na. All right, and it's going to produce sodium nitrate, NaNO3. All right, is that an ionic compound? Does it need to be dropped and swapped? +1, -1, is it good? Okay. And copper. Okay, is copper special? No, I mean it's got more than one charge, but I don't need to put a little number beside it. Okay, it's not one of those kind of special. Okay, now I've got to balance the whole reaction. Right now, what's out of balance is nitrate. There's 2 of them over here. So I need to put a 2 here. When I put that 2 there, how many sodium does that give me?
2.
What needs to go here? 2. Okay. Balance now? How many people have done number 3? Okay. So for number 3, I've got silver, Ag, nitrate, NO3. Is that an ionic compound? It is, okay. +1, -1. Is that one okay the way I wrote it?
Yeah.
Okay. All right, is reacting with lead 2 phosphide. So lead is Pb, the Roman numeral tells me it's the 2+ lead, and it's with phosphorus, which is a -3. Okay, so when I drop and swap, Cd3P2. Okay, what kind of reaction is that? It's a double replacement reaction. They're both ionic compounds. Okay. In a double replacement reaction, the metals get switched, but they tell us what the products are. Okay, they tell us that it's silver phosphide and lead 2 nitrate. Okay, are those both ionic compounds? What do I need to do to both of them? Right. Okay, so silver is a +1, phosphorus is a -3, Ag3P, and lead is a 2+. Nitrate is a 1-. Here's another example of necessary brackets. Okay, 2 outside of the brackets. Okay, this is a trickier balance. There's a lot of little numbers on this one, right? Okay, so which one should I start with? Biggest, okay? Biggest is both silver and lead. Which one should I do first? One with the bigger charge. Silver's a 1, lead's a 2. Okay, so I've got 3 lead atoms over here. So what needs to go in front of lead 2 nitrate? Okay, when I put that there, how many nitrates does it give me? 6. Okay, 3 times 2. Okay, so I got to go back over here and put what in front of this? A 6. Okay, how many silver does that give me? 6. So what needs to go in front of this? Right. Okay, does that give me 2 phosphorus? Yeah. Are there 2 over here? Yep. Okay. Now, something I think that happened to a few people on the quiz was they couldn't get the reaction to balance. If that happens, 95% of the time, it's because you haven't dropped and swapped one of your ionic compounds correctly. Okay? Reactions will balance if all the parts of them are right. Okay? So if you've gone back and forth, back and forth, back and forth, and you can't get the reaction to balance, double check all your ionic compounds, or double check for a special element that maybe you forgot. Those are the culprits most of the time. Okay? You've forgotten to drop and swap something, or you just didn't do it right. That's usually why it won't balance. Okay? All right. Well, let's have you guys try the last 2 there. Okay, let's look at this number 4 here. So we got disulfur trinitride. What kind of compound is that? Molecular. Okay, di means how many? Okay, tri means how many? Okay, and it breaks down. So what kind of reaction is that? Decomp, right? All right, and it's going to break down into sulfur and nitrogen. Anything wrong? Special, both of them. Okay. How special is sulfur? 8, yeah. How special is nitrogen? Yeah, it's only normal special. Okay, 2. Okay. All right, now I got to balance this mess. What do I balance first? The highest. Yeah, I go with 8. Okay, but I got 8 on this side, and I've got 2 over here. Okay, so what do I need to put in front of this? 4. All right. When I do that, it gives me how many nitrogens? So what needs to go in front of nitrogen here? Okay, going all right with that. Sometimes people get thrown by big balancing numbers. You're going to get them sometimes, especially when sulfur is involved as an element. Okay. All right, and then we got number 5. What kind of reaction are we looking at in number 5? Yeah, C9H20. Whoa, I don't know why that looks that way. Terrible. Okay, 20. And plus oxygen gives carbon dioxide and water. Okay. Do I need the rule of 2? No. 9 is an odd number. All right, I've got 9 carbons over here. Now I've got 9 carbons over there. I've got 20 hydrogens on the reactant side. 10 times 2 is 20 hydrogens on the product side. Now I do the oxygens. There are 9 times 2 is 18 oxygens here, plus 10 times 1 is 10. So So I've got 28 oxygens. What times 2 gives me 28? Now it's balanced. Feel it? You may. All right, is that making some sense? All right. Now, tip here for you, okay, before we get back into balancing and predicting. How often have I assigned homework? The lab reports. Those are the only 2 things I've assigned for homework since we started the year. And that's basically, I mean, yeah, I give you the practice quizzes, but okay, I don't like mark those. Now the reason I do that, guys, is to give you time to do some homework on your own that I don't assign. Right? Now I'm not saying you need to slave over your science 2 hours a day. Okay, so I'm not saying you need to spend 2 hours a night on your science every night. That's not only unrealistic, it's probably unhealthy. Okay? But what I am saying is that it's not a bad idea to sit down and spend 10, 15 minutes a night on science. And by that I mean practice the stuff that we're working on. Okay? So if we've been working on reactions, do you have a whole bunch of worksheets with the keys? Okay, there's a reason I give you those. So you can go home and pick 3, 5, and just do them. And then check your answers. Okay? And then be honest with yourself. If you got them all right, 100%, you didn't have to correct a thing, you're good, right? But if you had to make some corrections, especially if you had to make the same correction a few times, that's probably something you should come and see me about. Okay? Pop in and see me for help. Now, when you pop in to see me for help, do you get chained to the desk and kept here for hours? No. Okay? You pop in and see me and we fix the problem. And it doesn't usually take very long. Okay? Like, I had a kid in my physics class yesterday, and he said to me, he actually wrote on his quiz, Mr. Coderre, I don't get this, got like 0. Like, I don't get this, and I need to come and see you after school for help. I looked at his quiz and I'm like, oh man, we're gonna be here for like a half an hour at least. Okay, because like, it doesn't seem like he knows how to do this. And I put a question up there, I said, okay, draw this. He drew out the diagram, and I said, okay, this and this, what do we do with it? And he just looks at me and goes, oh crap, that's what I was doing wrong? We were there for 2 minutes, okay, and we found the source of his problem. He knew how to do everything, he just missed one step, and that's usually the way it is. Okay? If you're really struggling with something, it's usually because one little piece isn't there. Okay? So if you come in for help, you're not going to be here for hours and hours. Okay? And there's no shame in coming in for help. Okay? I'll probably think more of you for coming in for help, okay? Rather than less. Okay? Come in and ask questions. That's okay. That's what I'm here for. I got no life. I'm here all the time, so come and see me. Okay? And the same goes for your lab reports. Come and see me. Get me to look them over. Right? Let's try a couple of balancing ones here. I would like you guys to try 1 through 7 here. 1 through 5 are pretty straightforward. They're just balancing, and it's in the workbook. So if you have the workbook printed or whatever, okay, this is one of the worksheets. Okay, but I want you to try 1 through 7. 6 and 7 are a little trickier, right? They're kind of like the first reaction in the lab yesterday. So doing those might help you a little bit with that reaction. Right, so I'm going to give you a few minutes to do the balancing on 1 through 7, and then we'll walk through a few of them. Okay, so first reaction there, what kind of reaction is that? Synthesis, yeah. Okay, we got 2 elements reacting to form a single compound. Only thing that's out of balance is chlorine. So I put a 2 there to balance the chlorine, but that gives me 2 potassium, so I got to go back here, put 2 potassium in. Since it's fill in the blank, I should put a 1 in place. Okay, those ones are pretty straightforward. Okay, and number 2, is it basically the same reaction? Yeah, I just swapped bromine for chlorine. Okay, so going to be the same numbers there, 2, 1, and 2. Now, number 3, is that also a synthesis reaction? Yes, it is. All right. Right now, I've got to balance the oxygens there, what's out of balance. So you got to put a 2 here to balance the oxygens. How many potassium does that give me? 4. Okay, that one I think was on your quiz yesterday. All right, for number 4, another synthesis reaction. Okay, and they tend to be the easiest ones to balance. Okay, but I've got sodium going together with nitrogen. My biggest number is sodium, but if I just come back here and put a 3 here, am I going to have to change it right away? Yes. Yeah. All right, so I'm going to balance the nitrogens first by putting a 2 here, which gives me how many sodium? 6. Okay, and then a 1 there. All right, number 5, also synthesis reaction, strontium and nitrogen. Biggest number is 3. That's the only thing we have to do for that one. Okay, those ones are all pretty easy. Are 6 and 7 quite a bit more involved?
Yeah.
Yes. Why?
I can't read the numbers for this. What is number 7?
NH4 bracket 2, SO4, and then NaOH, NH3, HOH, Na2, SO4. This is in the workbook too. This is one of the pages in the workbook. All right, now what makes these ones difficult is that they're very much like the first reaction in yesterday's lab. Ammonium is involved, but ammonium splits apart into ammonia and hydrogen. Okay? This is where that extra hydrogen that was here ends up. Okay? It kind of helps to track a little bit. If you're wanting to break the reaction down to track everything, that's how you would do it. I would say that the quicker way to solve this, to balance it, is to just obey the rules we went over before. Start with the biggest number. That's either hydroxide or chlorine. Okay, I'm going to start with chlorine. There's 2 chlorines over here. How many are there here? 1. So what needs to go in front of this? Okay. When I put that 2 there, how many nitrogen does that give me? How many nitrogen? 2, right. Okay, so I'm going to go over here and I'm going to balance my nitrogens by putting a 2 there. And I'm going to remember that while, yes, there are 8 hydrogens on this side, I'm balancing it element by element now, okay? There are 2 times 3 is 6 here, and another 2 here, which I would have got without having to go through that thought process if I'd have just balanced my hydroxides. I would have had to put a 2 there anyway to balance the hydroxides, and it would have worked. Without having to think that reaction through, I could have just followed my rules and made it work. Okay, so this is going to be a 1, and that's going to be a 1, and that's going to be balanced. Yeah, it's a little trickier though when they're not just our standard reaction types. Yeah. Okay, try number 7. Basically the same reaction. All I did was swap out sodium for calcium. Yeah. Okay, so it works very similar. See if you can get it now that you've seen one done. Okay, so if we're just looking at number 1 here, okay, probably most of you wrote it like this. K plus H2O. Okay, what kind of reaction is that? Single replacement, yeah. The potassium is going to replace the hydrogen. Okay, so we end up with hydrogen gas plus potassium hydroxide. Okay, now when you throw potassium in water, it explodes. Okay, reason for that, it makes hydrogen gas, which is that same gas. If you saw me lighting the splint over people's reactions yesterday, that's the gas I was burning off. Okay, so when I got to balance this here, my hydrogens are already balanced, but my potassiums are not. So I need to put a 2 here, okay, and that should take care of everything. That's one way to write that reaction. There's a second way that's also right. Okay, you could write it like this. I can write water as HOH, but if I do, it actually gives me different products. It's still a single replacement reaction. I'm still going to get hydrogen gas, but I'm going to get KOH as a product instead. Okay? And to balance that one, I have to put a 2 here, and 2 here, and 2 there. Both of those are right, because in actuality, they both happen when you throw potassium in water. Okay? Both of those products are produced. Okay? All right. I want you guys to try 3, 4, 5, 6. I think that's it for now. 3, 4, 5, and 6. Keep in mind on these your special elements. okay, as well as, oh no, you don't have any polyatomics in there, so just special elements. Be on the lookout for the special elements, okay, when you're doing this. Give you a few minutes and then we'll walk through those together. All right, let's look at these ones here. So we got magnesium solid. What does that look like? What's the formula for magnesium? Mg. Okay, it's not special. Okay, nitrogen gas, is that special? Yep, that's the thing people forget often when they're doing this reaction. Okay, they react with each other. What kind of reaction is that? Synthesis reaction. Okay, synthesis. Okay, and that's going to mean forming Mg, okay, with N. That's an ionic compound, so I need to drop and swap it. Okay, Mg3 and 2. All right. My nitrogens are already balanced, so all I have to do is put a 3 here to balance my magnesium. Okay. Questions on that one? All right. In the next one, there's a trick, okay? And I use it all the time on quizzes and sometimes on tests, just to check if people are paying attention, okay? So I've got phosphorus, which is 4. That's not the trick, okay? And it reacts with lithium. Okay, what kind of reaction is that? Synthesis, okay? In a synthesis reaction, what do these two things do? They combine. Anything wrong with what I wrote? Right, phosphorus is in front of lithium. What kind of compound is going to be formed when lithium and phosphorus combine? Ionic. What gets listed first? Metals. That's what that question is checking. Okay, that question is checking. Do you remember the simple rule that involves ionic compounds and the metal always being listed first? If I put it in that order, I will catch, on a good day, 25% of you at that. Because you just forget. When you get a little bit anxious, you're on a test or a quiz, whatever, you just forget. You forget that little rule. Okay? So, now that I've got an ionic compound, I need to drop and swap. That's a +3, or sorry, -3, that's a +1, Li3P. And now I've got a balance. What should I balance first? Biggest number, phosphorus. Put a 4 in front of this. How many lithium does that give me? What's 4 times 3? Okay, so little things to watch for, right? But they're the kind of things that'll catch you and cost you marks. Okay? That's the kind of thing you get if you've practiced. Okay? Little things like that won't catch you if you have the experience gained by doing a fair amount of practice. Okay, number 5, iron 2 sulfide. So iron is Fe. The Roman numeral tells me it's 2+. It's with sulfur, which is 2-, so that compound's okay the way it's written. Okay, reacts with oxygen gas, O2. That's going to give me F. What kind of reaction is this? It's what? Nope, not a decomp. Single replacement, right. I've got an element reacting with a compound. So Fe is going to end up with O, and S is going to end up by itself. That's a -2, that's a +2. So I've checked my drops and swaps, check for special elements, got one. Okay, so I've got to put an 8 here, an 8 there, and a 4 there. Okay, all right, we got one more here, and we got just enough time to do it. Okay, molybdenum, MO, +6. It's with sulfur, -2. What does that compound look like? MOS3. What do I have to remember about ionic compounds? Right, I got to put them in their lowest terms, or I have to reduce them down. I can't leave it as 2 and 6 when it can be 1 and 3. Would I get people on that one? Would I do that to you? Yes, I'm a jerk. I would totally do that. Okay, all right, it reacts with oxygen gas. Okay, that's going to produce exactly the same problem over here. That's a -2, that's a +6, so we got the same thing, plus S8. The balancing's a little tricky on this one as well. Lowest common multiple of 8 and 3. 8 and 3, the lowest common multiple is 24. Put an 8 here and a 3 there, okay? And then I need to put an 8 here. 8 times 3 is 24. So I need to put a 12 here, okay? Big numbers throw people sometimes, but those are the right numbers. All right, tomorrow's quiz is exactly the same format as Tuesday's. There will be 3 questions with the reactions in formula form. You'll have to write them out, identify the type of balance, 3 in word form, written out, balanced, typed. Okay? It'll post at 3:20, so check it out tonight.